Hello everyone, today we are going to look at the circuit of a sound light dual control light. This circuit is relatively common in sound light control lights in corridors. It consists of basic components and basic logic devices. It is relatively simple in structure and working principle, and the manufacturing cost is relatively low. The reason why it is called a sound light dual control light is that sound control is mainly used for control. This light switch and light control are used to identify the intensity of light. When the light is strong enough during the day, this light cannot be lit. Next, let's take a look at the basic composition of this circuit. On the far right side of this circuit, 4 diodes form a full-wave rectifier circuit. The hole gauge here is used to control the one-way hole gauge. A light switch. R7 and VD5 here are used to step down and stabilize the voltage to provide working power for the subsequent logic control circuit. C2 and R5 here are delay control circuits used to control the delayed turn-off of this light. The component B on the left is a beaded tube used to identify sounds. VT7 is a 3-stage tube used to put there are some lights on the signal side of the large beaded tube. There is a photometer resistor used to identify the intensity of the light. The 4 in the middle are 4 logic circuits and 4 NAND gate logic circuits. One of them is to judge the logical relationship between sound and light. The other is used to shape the signal. Let's take a look at the working principle of this circuit. Before understanding the working principle, first let's understand the working principle of this logic circuit. The logical relationship of the 4 first, second, third and fourth is 4 NAND gates. Each NAND gate has 2 input terminals, so it is called a 2-input NAND gate. What is its logical relationship? This is what I drew below. When the 2 input terminals are 1 at the same time, that is, the battery is high at the same time, its output battery is 0, which is a low battery. When any signal is 0 or low battery, its output is a high battery. First, let's take a look at the working status of this circuit when the light is strong enough during the day. 22 after 0 volts is rectified by 4 diodes. It will become a DC voltage at these 2 points. It will be stepped down by R7 stabilized by VD5 and filtered by C3. Then a low voltage will be provided behind this place to provide working power for the logic circuit behind it. When the light is strong enough during the day, what about this light? The resistance of the sensitive resistor will be relatively low, so the potential at this point is 0, which is low battery. So the first logic gate circuit has 2 input terminals and 1 low battery. Then this circuit will be connected to this circuit of this circuit. This part of the circuit is connected to the photoresistor, which is used to identify light signals. The other input end is connected to this beaded tube, which is used to identify sound signals. When the light intensity is relatively high during the day, one of the input ends of this logic gate circuit is 0, which is low battery. Then when one of the input terminals of the UFE door is a low battery, its output is a high battery. That is to say, when one input is a low battery, there is no need to judge the battery relationship of the other input terminal. No matter whether the battery of the other input terminal is high or low, its output is always 1, and it is always a high battery. What changes is that when the light is strong enough, this part of the sound recognition is invalid, regardless of whether there is sound or not. Its logical relationship remains unchanged. The second, third, and fourth input terminals are connected. The 2 input terminals are connected. Its logical relationship changes from a rain fly gate to a fly gate, which is the reverser. Its function is the battery logic relationship between the input end and the output end. The output is 0, the output is 1, and the input is 1, the output is 0. So what are the functions of the inverter? There are two here. One is reverse and the other is used to shape the signal. Because the input signal of the front microphone is a pulsating signal, including this photoresistor. The battery it inputs is not completely high battery or low battery, so after the shaping of this inverter, it will become a standard square wave signal. During the day, the battery output by the first logic gate is high battery 1. After the reverse of the second logic gate, its battery will become 0 low battery. Then the input signal of the third logic gate is also a low battery, and its output signal is a high battery. After the fourth reverse direction, it outputs a low battery. At this time, the gate ridge of the Kion gauge cannot get the trigger voltage. At this time, the Kion gauge is in a cut-off state, and the light cannot be lit. Below, let's take a look at the state of the dark sky. When it is dark, the resistance of the photoresistor will become relatively large. Then the battery at this point will become high. Battery 1. The signal of the front microphone is amplified through the VT7 triode. Then the cable R1 provides bias for the bead relay microphone. The voltage setting cable R2 provides a bias voltage to the triode. When there is no signal input, that is, there is no sound, the collector of the triode outputs a low battery signal. Then the logic gate also outputs a high battery. That is to say, during the day or dark when the light is relatively weak, there will be no power. When there is sound, its output state is high. When the battery is high, its state is the same as when the light is strong during the day. Then to the door level of the last controllable cabinet, its battery is 0 and it cannot get the trigger voltage. So when a sound signal comes in, its signal is amplified by the triode. The output of this collector is high battery 1, T is, this input terminal becomes 1. Then at this time, the first input terminal becomes 1. Both input terminals of the first logic gate will become high battery 1. Then the output terminal of the first logic gate will become a low battery 0. Then what about this low battery after the second reverse direction? So at this place it will become high battery 1. High battery 1 passes through the diode VD6. Then at this place, the third input terminal will also become 1. Then the third output terminal will become 0. After the fourth reverse direction, the fourth input terminal will become 1. Then this high battery will provide triggering current to this audible gate level. So at this time, the light will light up, but because the sound signal is intermittent, the state of the light will become a flashing state according to the sound signal. But there is a battery on the third input end, which is the capacitor C2. Then when a sound signal comes in, the potential at this point becomes high battery 1 is to charge capacitor C2, which means that the potential at this point will not change suddenly with the change of sound. When a sound signal comes in, the capacitor will be charged. That means that the potential at this point will slowly drop from 1 to 2000. So at this time, the light at the back will not change due to the disappearance of the sound signal. The signal immediately turns into a cut-off state and changes from the on state to the off state. It will control the delay of the lamp by the charging and discharging of the capacitor. So there is an R5 on the capacitor. When the sound signal does not come in, the capacitor will discharge to R5. So when it is discharged when the battery is low to a certain extent, as low as 0, when the battery is low, the rolling gauge will be cut off. So every time a sound signal comes in, the capacitor CL will be charged. When there is no sound signal, the CL will discharge to R5 until the discharge reaches a low battery, then the light will go out. So because of this place, use it is a single wire battery, a single wire thyristor, and a single wire thyristor has a self-locking effect, that is, after starting, it will stay on from the cutoff state. However, since the 220 volts in front are not filtered by the capacitor, the DC signal here will have a zero crossing voltage, so this can because the thyristor crosses zero, it will become cut off, which means that it has no self-locking effect. When the thyristor is turned on, it is equivalent to 220 volts coming in, and then rectified by the diode to provide the working voltage to the lamp. That is, the working voltage on the lamp is actually DC, but because the thyristor is turned on, it is not completely conductive. It has a certain internal resistance, so when the thyristor is turned on, the circuit behind it will not be completely short-circuited, so it will be completely short-circuited. When the lamp is shining, the circuit behind it will continue to maintain its work. So when this kind of lamp is working, the voltage on the lamp cannot be equal to this 20 to the voltage of 0 volt is because there is a certain conduction voltage drop on the thyristor. The advantage of this circuit is that it only needs to be connected with two wires, that is, a two-wire circuit. It only needs to be connected with two wires, and the switch can be directly connected to a standard, such as an 86 switch box. It can be used directly without the need for a separate zero connection. Line. Its disadvantage is that it cannot control relatively high power circuits and inductive loads, as well as dimming circuits. This kind of circuit, this sound and light control circuit, uses a basic logic device. Its structure is relatively simple. Some current circuits will have some specialized. The control chip used is a dedicated sound and light control chip. Its use will become simpler. In terms of setting parameters, such as the sensitivity of the sound and light control, the sensitivity of the light control, and the delay time, it will be relatively simple to control. So in this circuit, if you want to control its delay time requires changing the values of the two components CR and R5. To change the sensitivity of the light control, you need to adjust the organization of the potentiometer RP. So some current circuits will become simpler in terms of control and parameter adjustment, and there will be fewer peripheral components. This is just one of the control methods, is voice control and light control. Now there are some control circuits. For example, the infrared of the human body is the control of thermal test electricity. It is also used to detect the movement of people at the same time as the light control. The light will only light up when someone passes by. One disadvantage of sound control is that it will be interfered by external noise. Interference may cause the lamp to accidentally trigger. The control of the hot test battery will avoid this situation. Only when people pass by, the light will light up. This plays an energy-saving role. We will also talk about one of the working principles of the hot test battery later. That's it for today's video. Thank you for watching. Goodbye.